Welcome all. In our next session of bisection method, we have already seen the concept of bisection method in previous video, but in this video, we'll solve some another examples of bisection method. In exam, we have given like this: find root of x cube minus 6x plus 3 is equal to 0 using bisection method up to 1 iteration, 2 iteration, or 3 iteration. Maximum we have to solve it up to 3 iteration. So let us solve this example. First, given this equation, denote it by f of x. F of x is equal to x cube minus 6x plus 3. Okay, say it as equation 1. Okay, now we don't have trial points, so what we have to do here, we have to find trial points. Okay, we don't have trial points, so we have to find trial points. It will start from 0, that is f of 0. Okay, so put x is equal to 0 in this equation 1. Then we have 0 cube minus 6 into 0 plus 3. Okay, so 0 minus 0 is 0. The answer is 3, which is greater than 0. Okay, next, f of 1, that is 1 cube minus 6 into 1 plus 3. You can see 1 minus 6 plus 3. 1 minus 6 minus 5 plus 3 is minus 2, which is less than 0. So you can see here one answer is positive, one answer is negative. So we get two trial points, that is 0 and 1. So what we have to write here, root lies between 0 and 1. Now we have to update this line 0 and 1. Okay, 0 and 1. These are our two trial points. F of 0 means this value. F of 0 is equal to this value 3, but we have to take sign only, that is positive. F of 1, the answer is minus 2, but we have to take sign only, that is negative. Okay, now what we have to do here? We have to find first iteration. First iteration. First iteration means first value, that is x1. X1 is addition of these 2 points divided by 2 means midpoint, as this is bisection method. 0 plus 1 divided by 2. 0 plus 1 is 1, divided by 2 is 0.5. Okay, so we have to write 0.5 here. Now we have to put this value in equation 1 also. Okay, whatever the new value of x1, x2, or x3, we have to put this value in equation 1 for checking the answer is negative or positive. Okay, so I will put this value f of 0.5 is equal to equation 1, 0.5 cube minus 6 into 0.5 plus 3. Okay, you can solve this on calci also. 0.5 cube minus 6 into 0.5 plus 3 is 0.125. So this answer is positive, that is greater than 0. So update this line positive. Okay, now this 0 is also positive and 0.5 is also positive. So this side will get cancelled. Then root lies between 0.5 and 1. So we'll write here root lies between 0.5 and 1. Okay, so What do we have to do here? Next, 1 second. Next, we have to find midpoint of these two trial points. New trial points are 0 0.5 and 1. So we'll go to next step, that is second iteration. So second iteration means x2 and the addition of these two new trial points 0 0.5 plus 1 divided by 0 0.5 plus 1 is 1.5 divided by 2 is 0 0.75. So in this line we have to write here 0 0.75. Now we have to check answer of this is negative or positive. For this we have to put this value in equation 1 again. So right here put x2 is equal to 0 0.75 in equation 1. Our equation 1 is f of 0 0.75. Equation 1 is x cube minus 6x plus 3. You can see here x cube minus 6x plus 3. So x cube means 0 0.75 cube minus 6 into 0 0.75 plus 3. By using calci, you can solve it. The answer is minus 1.078, which is less than 0. So we have new trial point 0 0.75 and the answer of this will be, this is negative. Okay, so answer of this is negative. So which side will get cancelled? This side will get cancelled. Then root lies between these two trial points, that is 0 0.5 and 0 0.75. So we'll write here root lies between 0 0.5 and 0 0.75. Okay, now third iteration. Third iteration x3 is equal to addition of these two trial points, new trial points 0 0.5 plus 0 0.75 divided by 2. Okay, 0 0.5 plus 0 0.75 is 1.25 divided by 2, that is 0 0.625. 1 second. Our answer is 0 0.625. Therefore, x3 is equal to 0 0.625 is approximate root of given equation, is approximate root of given equation. So in this way you can solve bisection method by using this concept. Okay, now we'll see some another example. If we have given example of this form, we know the exponential function. We'll write method and equation bisection method. And if we have given the equation e raised to minus x is equal to 0. Okay, and we have to solve this equation up to 3 iterations. All of us know the exponential function, that is bisection method, e raised to minus x. Okay, we have to simplify this equation like this. E raised to minus x will be 1 upon e raised to x. Okay, e raised to x minus x is equal to 0. 1 second. sorry, say this as equation 1. Okay, so what we have to do here, we have to simplify. This e raised to minus x will be 1 upon e raised to x. Now we don't know the trial points, so what we have to do here, first step is find trial points. Find trial points. Start from 0. F of 0 is equal to 1 divided by e raised to 0 minus 0. And all of us know that something raised to 0 is 1. So e raised to 0 is 1. 1 divided by 1, 1. 1 minus 0 is 1, which is greater than 0. It is positive. F of 1 is equal to 1 divided by e raised to 1 minus 1. Okay, and can see there is one button of exponential function. So 1 upon e is 0.3679 minus 1. So the answer will be minus, you can solve it directly, minus 0.6321, which is less than 0. So answer will be negative. So these are our two trial points. So we'll write here root lies between 0 and 1. Root lies between 0 and 1. Okay. So we'll update this line. 0, 1. Those two trial points. F of 0 is positive. F of 1 is negative. Now we'll solve first iteration. First iteration means what? X1. First iteration x1 is equal to addition of these two trial points divided by 2. 0 plus 1 divided by 2. 0 plus 1 is 1 divided by 2 is 0.5. So our first iteration is 0.5. But we have to check the answer of this is negative or positive. So what do we have to do here? Put this value in equation 1. Put x1 is equal to 0.5 in equation 1. Okay, then equation 1 will be f of 0.5 is equal to 1 upon e raised to 0.5 minus 0.5. In Calc, you can solve it. The answer is 1 upon e raised to 0.5 is 0.1065, which is greater than 0 because it is positive. So it will be positive. So the sign positive, positive will get cancelled. The remaining roots are 0.5 and 1. Remaining interval. So we can write here root lies between 0.5 and 1. Okay. So now what do we have to do here? Next iteration, we have to find midpoint of this two. Okay. So say it as second iteration x2 is equal to 0.5 plus 1 divided by 2. 0.5 plus 1 divided by 0.5 plus 1 is 1.5 divided by 2 is 0.75. Okay, so we'll update this line 0.75. Now we have to check f of this value is negative or positive. So what we have to do here, put this value in equation 1. Put x is equal to 0.75 in equation 1. Okay, then our answer equation will be f of 0.75 is equal to 1 upon e raised to 0.75 minus 0.75, because our equation is 1 upon e raised to x minus x. Okay, so the answer is minus, you can solve this on calci, minus 0.2776, which is less than 0. So we'll update this line. The answer of this is negative. So which side will get cancelled? This negative negative is same. So this side will get cancelled. So our new interval is 0.5 to 0.75. So we'll write here root lies between 0.5 and 0.75. 0.5 and 0.75. Next one is third iteration. Third iteration. Third iteration means we have to find x3. Addition of these two trial points divided by 2. That is 2 points, 0.5 plus 0.75 divided by 2. That is 1.25 divided by 2 is 0.625. After 3 iteration, we have this answer 0.625. Maximum we have to solve this method up to 3 iterations. Thank you.